Antarctica is a white blanket of the unknown. 66 million years ago, this continent was a paradise covered in lush rainforests where dinosaurs roamed. But why is it completely covered in glaciers today? What secrets lie beneath our planet's coldest and most isolated continent? Myths and conspiracy theories aside, what are scientists discovering beneath the 4-kilometer-thick ice sheet? Lake Vostok, the world's sixth-largest lake, has existed in liquid form for 15 million years. Giant mountains the size of the Himalayas, trapped in glaciers, and underground tunnels formed by active volcanic activity. Now, we're embarking on a journey into the depths of this mysterious continent and discovering the secrets of time capsules buried beneath the glaciers. We're traveling back 66 million years to the time when dinosaurs disappeared. Antarctica isn't as isolated as it is today. It has a mountainous landscape surrounded by forests and lush vegetation and a very mild climate. Temperatures in summer are around 20 to 25 degrees Celsius, even above freezing in winter. The vast forests are home to many species. Dinosaurs lived in this region and fed in the forests of Antarctica. The supercontinent of Gondwana is still in the process of breaking up. At that time, Antarctica was connected to Australia and South America, allowing animals to migrate from South America to Australia. It would be another 32 million years before South America broke away from Antarctica and the Drake Passage formed. Meanwhile, the Drake Passage today extends from the sea surface to a depth of 4,800 meters. It is famous for its violent seas, with waves exceeding 12 meters and strong currents flowing at speeds of up to 150 million cubic meters per second. Cold water from the Southern Ocean and warmer water from the north collide here, creating powerful and energetic eddies. 66 million years ago, an asteroid approximately 15 kilometers in diameter struck Mexico's Yucatan Peninsula, creating the Chicxulub crater, 180 kilometers across and 20 kilometers deep. The impact released an energy equivalent to 100 million megatons of TNT, triggering a process known as nuclear winter. Dust and sulfates released into the atmosphere blocked sunlight, lowering global temperatures. They collapsed ecosystems and triggered the extinction of the dinosaurs. Much of the crater lies beneath the land and ocean layers today. Although Antarctica was a warm and forested continent at the time, this temporary cooling affected its ecosystems. However, it was still 32 million years before Antarctica began to be covered by glaciers. During the intervening 32 million years, tectonic plate movements separated Antarctica from South America and Australia. On the one hand, the Southern Ocean, a completely open sea passage between Antarctica and Australia, formed. On the other, the Drake Passage between Antarctica and South America, creating the Antarctic Circumpolar Current, further reinforced Antarctica's isolation. The opening of this passage isolated Antarctica from warm ocean currents, leading to the rapid cooling of the continent and the formation of glaciers. Isolated from warmer waters, the surrounding waters of the continent cooled. CO2 is a gas that traps heat from the sun in the atmosphere, keeping the Earth warm. More CO2 causes warming due to the accumulation of heat in the atmosphere, while less CO2 causes the Earth to cool. The cold water around the continent absorbed CO2 from the atmosphere, lowering CO2 levels. Snowfall increased, and the formation of permanent ice began. Mountains, lakes, forests, and animal fossils continued to be buried under more and more ice sheets. It took until 5 million years ago for the entire continent to be covered by glaciers. 5 million years ago, Antarctica's glaciers were relatively young and less compressed. Newly formed ice sheets were generally thicker and lighter, resulting in greater height than today. Years of snowfall and new ice compressed the older ice sheets beneath, reaching the present day. This caused the ice sheet to decrease in height, but there was no significant decrease in mass. If all the glaciers on this continent, which contains 70% of the world's total freshwater reserves, melted, sea levels would rise approximately 60 meters, and Topkapi Palace would be 20 meters below sea level. Antarctica is the world's largest ice sheet and has the thickest ice mass. East Antarctica is colder than the west, which is why the ice sheet is thicker there. Here, ice thickness generally exceeds 3 kilometers, reaching up to 4.8 kilometers in some places. In the west, it generally varies between 1 and 3 kilometers. Antarctica has no vegetation other than mosses, lichens, and some microscopic plants. There are approximately 70 active research stations on the continent, including the United States' McMurdo Station, Russia's Vostok Station, and Turkey's Turkish Scientific Research Camp. Established by Turkey in 2019, this camp was the first concrete step toward Turkey's goal of establishing an institutional presence on the continent and sustaining scientific research, and is the starting point for a permanent Turkish scientific base planned for the future. Turkey is carrying out these projects to support its goal of becoming a consultative state within the Antarctic Treaty System. The lowest temperature ever measured in Antarctica was recorded at Vostok Station in 1983, minus 89.2 degrees Celsius. On January 27, 1820, Bellingshausen, a captain in the Imperial Russian Navy, made the first recorded sighting of the Antarctic continent. At the time, he was leading an expedition whose flagship was the Vostok. Vostok means east in Russian. In 1957, the Soviets constructed a research facility in Antarctica, in a highly isolated area approximately 1,300 kilometers from the geographic South Pole. To honor Bellingshausen's adventure, the facility was named Vostok Station. The name was quite telling. Vostok Station was built on the East Antarctic ice sheet. While examining seismic data collected in the 1950s, Russian geographer Andrei Kapitsa began to suspect that a large liquid lake might exist beneath the ice sheet in East Antarctica near Vostok Station. Scientists use ground-penetrating radar technology to measure the thickness of ice sheets. This method first sends high-energy radio waves to glaciers, ice sheets, or ice caps. If the echoes were returned, they could reveal important information about the structural properties of frozen water. In the 1960s and 1970s, this technology began detecting sub-ice lakes across Antarctica. As it turned out, Kapitsa's prediction was entirely accurate. A radio echo survey and satellite measurements finally confirmed the existence of a massive lake buried near the Vostok Station. This discovery was announced in the journal Nature. How could a lake remain liquid without freezing under approximately 4 kilometers of ice? Because of the approximately 4-kilometer thick ice layer between the surface and the lake, Lake Vostok had not been directly explored by humans. However, seismometers and ice-penetrating radars have yielded important information about the lake's structure. The elongated lake was discovered to be approximately 250 kilometers long and 50 to 80 kilometers wide. Its 5,400 cubic kilometers of liquid water, extending to a depth of 500 meters, astonished scientists. Radar scans also revealed an island in the lake's central section. Scientists concluded that the immense weight of the ice sheet, exerting immense pressure on the water molecules above the lake, lowered the freezing point of water. Normally, water freezes at 0 degrees Celsius, but under high pressure, the freezing point of water shifts to lower temperatures. In Lake Vostok, the weight of the ice is thought to have lowered the freezing point to an estimated -2 degrees Celsius, to -3 degrees Celsius. This allowed the lake to remain liquid. Geothermal energy emanating from the Earth's interior also contributes to the lake's liquid state. Heat from the Earth's core continuously rises, melting the ice in the bedrock, preventing the lake's water from freezing. These two factors have allowed the lake to remain liquid under the ice sheet for 15 million years. Drilling began in 1990 and reached a depth of 2,503 meters by 1992. Drilling continued until 1998, reaching the accumulated ice sheet at a depth of 3,580 meters. This layer was the icy residue of the massive glacier above it. The lake was just beneath this ice sheet, and it was very close. But the work was abruptly halted. Microorganisms and other living things, preserved in a time capsule beneath the glaciers for 15 million years, it should not have mixed in any way with modern bacteria and microbes. Researchers feared that the toxic chemicals entering the water would not only taint the results of their research on the underground lake, but also threaten to destroy any life that might have existed there during its 15 million year isolation. So, the scientists were now faced with the task of developing a drilling method less hazardous to the ecosystem. 8 more years were devoted to this scientific research. Water sampling efforts only resumed in 2006. However, even with the new methods, the Antarctic expedition members were still unable to drill all the way to the desired lake. Russian scientists, who claimed to have developed this system, continued drilling. In 2008, the drill pipes became stuck at 3,668 meters. Either due to technical malfunctions or irregular funding, they were hampered. The high pressure and cold climate at the depths under study made the work extremely difficult. Finally, by 2011, the ice water boundary at a depth of 3,769 meters was reached. In a twist of fate, Andrei Kapitsa, who discovered this lake, passed away that same year. But problems persisted. Liquid water at this depth would freeze when drawn upwards towards the -60 degrees Celsius glacier. 2 more years of work were needed to solve this problem, and finally, the first sample was collected.